Okay, here's where we ended up yesterday. I'm not going to add any new problems to your assignment. I'm going to suggest a real cool problem number 8 that you might want to take a look at. And anyway, today, all we're going to add is the procedure to partial fractions when we have a common factor in our divisor. So like an x minus 2 quantity squared. How are we going to deal with something like that? So now suppose that the denominator has repeated linear factors. So p of x over q of x now would be p of x over, now look at this, x minus a sub 1 to the m sub 1 power, x minus a sub 2 to the m sub 2 power, and so on, x minus a sub n to the m sub n power. That makes it look a little complicated, but here's what's happening. Each factor x minus a sub 1 to the m sub, or a sub I to the m sub I power contributes the following sum of terms to the partial fraction decomposition. Okay, so that's going to create this situation right here, where I have an x minus a sub I, and then an x minus a sub I squared, and then an x minus a sub I cubed, and so on, until we get to x minus a sub I to the m sub I power. Now, more simply, that looks something like this. So this would give me an a over x plus 1. And then you can call these whatever you want. I like to go like b sub 1 times the quantity x minus 2. And then b sub 2 times the quantity x minus 2 squared. And there it is. And we do exactly the same thing. We're going to have one more little step here. All right, so let's solve this baby right here. So you guys see that we have what? An a over an x minus 1, a b sub 1 over x plus 2, and a b sub 2 over x plus 2 quantity squared. And now we're going to multiply both sides by the divisor on the left. So I'm going to get 3x minus 9 equals a times the quantity x plus 2 squared, b times the quantity x minus 1 times the quantity x plus 2, and then b sub 2 times the quantity x minus 1. And now we do our same thing. Let's let x equal, I don't know, how about a positive 1 there? So what's that going to give me? Well, 3 minus 9, that's a negative 6. And now I lose this term, I lose this term. So I have this term where my x is, what, positive 1? So that's going to be a 3 squared, or a 9a. So that would be a equals negative 6 over 9, which I would say is a negative 2/3. Now, let's let x equal, how about the negative 2? Okay, so negative 2, that'd be a negative 6 minus 9 more, negative 15. I lose this term, I lose this term, and I have what? A negative 3 b sub 2. So negative 15 divided by negative 3 would be a 5. b sub 2 equals 5. All right, now we got to substitute what we know into our equation right now, and then find a way to solve for our b sub 1. All right, so let's go. 3x minus 9 equals a, which is negative 2/3, quantity x plus 2 squared, and then b sub 1 times the quantity x minus 1 times the quantity x plus 2, and then b sub 2, which is 5, times the quantity x minus 1, right there. Okay, now we've got to solve for this b sub 1. There is no use substituting x equals 1 or x equals negative 2, because that would eliminate the term involving b sub 1. But we are free to plug in any other value of x. And I don't know about you, and your textbook and examples doesn't always do this either, but if I can choose any value of x I want other than 1 or negative 2, I'm going to use the 0. Okay, now let's see how clean this comes out here. So 3 times 0 minus 9 would be a negative 9, equals negative 2/3 times 4 plus b sub 1 times and that would be a negative 1 times 2. That's a negative 3. Or excuse me, negative 1 times 2 is negative 2. All right. And then I've got my 5 times negative 1, negative 5. All right. Now, we just have to solve this for b sub 1. And you guys know I'm at home in bed, so I don't have my calculator or anything. I'll do the best on my arithmetic here. All right, so the first thing I'd probably do is combine my like terms on the right. Yep. So I've got negative 8 thirds minus 15 thirds. That's negative 23 thirds. And then I've still got my negative 2b sub 1 there. All right. And now let's add 23 thirds to negative 27 thirds. And that's going to be a negative 4 thirds. So it looks like I'm skipping the steps. So if I take negative 4 thirds and I divide by negative 2, I've got 4 over 6, which is a 2 thirds. And there it is, 2 thirds. Look at me, Mr. Arithmetic. Okay, so let's put them all in there. So what was my A again? It's a negative 2 thirds. So I wrote that. And what is my B sub 1? A positive 2 thirds. And what is my B sub 2? That's a negative, where's it at? Where's it at? Or a positive 5, isn't it? There we go right there. And now we're ready to do the antiderivative of all of this stuff right here, which we're pretty darn good at. So yeah, we can do it. So let's rewrite this now as, let's bring the 2 thirds out and go dx over x minus 1. And then bring that, and that was a negative 2 thirds. Here's the positive 2 thirds. Dx over x plus 2. And then let's bring the 5 out and go a dx over x plus 2 quantity squared. Now, we can do the first two just like we have, natural logs. So let's go negative 2 thirds, the natural log of the absolute value of x minus 1, times plus 2 thirds, the natural log of the absolute value of x plus 2. And now you might be thinking you're going to go plus 5 times the natural log of the x plus 2 quantity squared and all that stuff. No, you're not going to do that. You're going to do this just like you would with a regular antiderivative we've been doing all year. Let's use substitution. So u is going to be the x plus 2, making the differential of u and differential of x. So this is going to become a what? Let's just look at this part right here. We got a u to the negative 1, or excuse me, a u to the negative 2, and my differential of u. And then that's going to be u to the negative 1 over negative 1, which I'm going to write as negative 1 over u. And then a plus c right there. And my u is x plus 2. Negative 1 over x plus 2 plus c. So I'm going to have this be the negative 1 over x plus 2, multiply that by 5. And I've got a negative 5 over x plus 2 plus c, and there's my final answer right there. So that is how we handle powers of common factors in this partial fraction stuff right there. Pretty easy, all right? And this is a supplement beyond even BC right here, okay? So there's the same problems right there, and you might check out number 8. Yeah, it's a cool problem. Thank you. You guys have a great day. I miss you.